Good morning, students. 11th standard, chapter 2, basic algebra. So first, we are going to learn about what is algebra. Algebra is a branch of mathematics in which one expresses relations among quantities. So symbols are used to represent these quantities. Those symbols are called variables. So using variables, we can express relations among quantities. The study of relations in mathematics is called the algebra. For example, I'll take a simple relation. 2x is equal to 1. So in this relation, the symbol, that is the variable, is x. So that relation, the study of relation, is called the algebra. So one more relation we can take, 3x plus 7 is equal to 0. So in this relation, the variable used is x. So the quantity, the variable, is used as a symbol. Okay, so that is the study of relation among the quantities in mathematics is the algebra. Okay, in 11th standard, variables are used in this chapter or representing real numbers only. Okay, first we'll go to the real number system. In that number system, so already you are very well in that. The first number is called natural numbers. So it is denoted by the symbol n. If you want to count the object, we'll use natural numbers. Okay, so natural number starts with 1, 2, 3, etc. So you know very well. So along with natural number, if you add 0, that set is called the whole numbers. It is denoted by the letter W. So to deal with loss or debts among quantities, so we will use negative numbers. So including negative numbers, 0 and positive numbers, that set is called integers. It is denoted by the letter Z. So next, the number, we are moving to rational numbers. The rational number is denoted by the symbol Q. It is in the form of m by n, where m comma n belongs to Z. That means m by n, in that the numerator m and the denominator n are called integers, and the denominator n should not be equal to 0. If you write x belongs to q, that means x is a rational number. So x, how it should be? It is in the form of m by n, that is in the fraction form. Okay, so see the example, minus 7 by 3. So you see that it is in the form of m by n and the denominator is not equal to 0. The numerator minus 7 and the denominator 3 are integers. So this number is a rational number. And 0. So when you say 0, you will say it is a whole number. Very well you can say. You can say it belongs to integer. Yes, we can say. And also we can say 0 is a rational number. So the 0 can be written as 0 by 1, 0 by 2, 0 by 3. So it is in the form of m by n. So we can very well write 0 is also the rational number. And 22 by 7. So it is in the form of m by n. So it is a rational number. And 7, 12 minus 5. It can be written as 7 by 1, 12 by 1 and minus 5 by 1. So those numbers are called rational numbers. In earlier classes, you have studied rational numbers are the set of terminating or infinite periodic decimals. Okay, you in earlier classes you have studied like that. You see that the set of terminating decimals. So terminating decimals means the decimal points, the points in the decimal place has to be terminated. You see the example 2.5. So here 5 is a decimal point. After that no point is there. So it is terminated. It is stopped after a one decimal place. So this 2.5, it can be written as 5 by 2. So 5 by 2 is a rational number. So that's why the terminating decimals, if you have, that is a rational number. The same way minus 5.0 is nothing but minus 5 by 1. Okay, and you can consider this 2.333 etc. That means this decimal places is not terminated, it is goes on. So if the numbers having the decimal in decimal representation, decimal points are infinite periodic. The decimal points are written as infinitely periodic. You see that this 3 is repeated infinitely. Okay, so this number is also a rational number, and this also it's 0.6666 etc. So it is not terminated, it goes on infinitely with the, it is repeated, 6 is repeated, so it is also a rational number. Come to this number 7.14527836231231231. See that the decimal place, the points in the decimal place, here you just come to now 231, 231, 231. It is periodically repeated. So, and it is not terminated, it is goes on. So therefore the set of terminating or infinite periodic decimals are also called rational numbers. Okay, so next we are moving to the topic, the number line. So it's a horizontal line with the origin to represent O. So it's a horizontal line if you draw, and if you represent the origin and the number is O. So to represent 1, you have to mark another point to the right of 0. And to represent 2, so you have to mark another point to the right of 1. So see the distance between from 0 to 1 is 1 unit. And the distance from 1 to 2 is 1 units. Okay. If you want to represent any positive rational number, where we have to mark in the number line. So the positive rational number should be marked to the right of 0. So what are the numbers now? Positive rational numbers are marked to the right of 0. So if you want to mark the negative rational numbers, it has to be marked to the left of 0. You see the sentence? If we put any positive rational number x to the right of 0 by x units. We put any negative rational number minus r. So minus r is a negative rational numbers. In that r should be greater than 0. So only if you consider r, it should be greater than 0. For example, minus 3. If you consider 3, 3 is greater than 0. So the negative rational number minus r, where we have to write? We have to write to the left of 0. So we can write this as minus r. Okay. If you consider two rational numbers, what is that? xy. xy belongs to Q means x and y are rational number. So it should be in the form of m by n. And you are having one condition. If x is less than y, if x is less than y, if it's so, where we have to mark x and y, x is to the left of y. Okay. And also we have the relation x less than x plus y by 2 less than y. You see now, x is less than y means x has to be marked to the left of y, and also we can write x less than x plus y by 2 less than y. Okay, to explain this, I'll take this example. 1 by 2 is a rational number and 4 is also a rational number. This 4 can be written as 4 by 1. So it is in the form of m by n. So 1 by 2 and 4 are rational number. You know very well 1 by 2 is less than 4. So where we have to write 1 by 2? 1 by 2 is written to the left of 4. You see the number line. So 1 by 2 is 0.5. So this is 1 by 2. Next we have to mark 4 here. So see that 1 by 2 is less than 4 means 1 by 2 is left of 4. And you see now 1 by 2. Here I have written x as 1 by 2 and y as 4. So what is x plus y by 2? It is the average of x and y. So here I will add these two numbers and divided by 2. So 1 by 2 plus 4 divided by 2. If you take LCM, it is 8 plus 1 by 2. By 2 is 9 by 4. Okay, 9 by 4 what it is? It is 2.25. What is 9 by 4? It is 2.254. 25. So this is 1 by 2. It is 0.5. 1 by 2 is 0.5 is less than 2.25 less than 4. We can write. So that's why I have said here, if x is less than y, x is written to the left of y and x less than x plus y by 2 less than y. So we'll mark all those things in the number line. Already I have marked 1 by 2 and 4. Now what is the average of those two numbers? 2.25. So it will be here 2.25, that is 9 by 4. Okay, so 1 by 2 less than 9 by 4 less than 4. Okay, so from this what we are concluding, between any two distinct rational number there is another rational number between them. So between any two rational number there is another rational number between them. So here we are going to ask one question. Have we filled the whole number line only with rational numbers? The answer is no. You see, for example, for that I'll consider the square of length 1. So the side of the square is 1. So here also 1. So if you take the diagonal, so using Pythagoras theorem, we can write it is a square root of 1 plus 1, that is root 2. So what can you say about root 2? So root 2 is according to this, so between any two rational number there should be another rational number. Yes or no? You see this root 2 is a rational number or not. So we'll see in that next class. Thank you, students.